question 3. It should not even take us time, okay? We should be able to do it in no time at all. Let's get to work. Question 3 is saying, use the squeeze theorem to evaluate the following limits. Then it puts a limit for us, which we have part A, which is saying the limit as x goes to 0 of x squared multiplying sine 1 over x. So now, if you ever see something which says use the squeeze theorem, just know that the limit which you have here is never going to be evaluated. You are never going to evaluate it. You're going to evaluate other limits and they're going to be able to get the solution for you. You are not going to evaluate this one. We use the squeeze theorem when we can't evaluate this. Okay, the one which you'll be having. Okay, so what does the squeeze theorem say? It just says, if you have a function, basically, if you have a function, let's just say you have a function like this, then you have another function like this. I'm going to just and then it does whatever it wants. And then you have another function which goes in between these two, like this. Okay, and we have, now let's call this our f of x. Then we have this being our g of x, okay? Then this one in between being h of x. So now, if we ever get the limits as x approaches maybe this point here, whatever, maybe it's point A, the limit as x approaches A, remember that the limit is just a y value. So if you ever get the limit as x approaches A being some value, let's say that value is, we can call it what? Maybe we can call that value D, okay? Or L, we can call it L. If the limit as x approaches this of f of x is equal to L, and the limit as x approaches A of g of x is also equal to L, then obviously it means that the limit as x approaches A of h of x, which is the middle one, is L. We're saying g of f of x is above f of x is above the h of x, okay? This f of x is above h of x, right? And this g of x is below h of x. So if the limit of the one above is L and the limit of the one below is also L, then obviously the mid one is going to be L. Okay, you get it? So obviously the limit of the middle term will be L. So all we have to do is we have to be able to have an inequality. We have to know a certain function. We have to have a certain function on the left, a certain function on the right. Evaluate those two, then obviously the middle one will have the same limit. Okay? Okay, so it's very easy. So now what we'll be doing is we can use it for these functions with sine and cos, because if you remember the graphs of sine and cos, they start at 1 and end at -1. They range between 1 and -1, okay? So they don't go above 1 and don't go below -1. So their range is between 1 and -1. So we can use that, okay? So we can say that here, sine of whatever, we don't care if it's 1 over x or 1 over x squared or x squared or whatever, sine of whatever is still going to be between -1 and 1. So we can say that sine of x is, or sine of 1 over x rather, because that's what we have here, sine of 1 over x, it starts at -1 and ends at 1, okay? So you're solving this limit. So you start by putting this, okay? You can say -1 is less than or equal to sine of whatever you had here, which is 1 over x, which is less than or equal to 1. Okay, sine of anything starts at -1 and ends at 1. We don't care what it is. Now here you can see that we have multiplied by x squared, and this is going to change. This is going to change where we start from where we end, because this is an extension. We are extending. This is a stretch. We did transformations, and we know when you multiply by something, it's a stretch. So we can say that this x squared is going to stretch this, it's going to stretch this, and is going to stretch that. So this, instead of just being -1, is going to be -1 times x squared, which is minus x squared, is less than or equal to x squared times sine 1 over x, which is less than or equal to 1 times x squared is just going to be x squared. So now we have made it like this. Now once we have this, then we can now solve by the squeeze theorem. We can find the limit as x goes to 0 of negative x squared, which is the lower one. What is it going to be? Well, it's a polynomial, so we just substitute, right? It's of negative x squared. So since this is a polynomial, we just substitute, okay? We put 0 where there's x, so it's going to be negative of 0 squared, which is just anything when you say 0 to something, it's just going to be 0. Then now we find the limit as x goes to 0 of x squared now. Okay, it's still this one, this limit, but we are not going to get for this one. We are now getting for this one above, okay, which is going to be equal to, we just substitute again, it's going to be 0 squared, which just gives us 0. So we can say, therefore, we can now use the squeeze theorem to then put our final verdict now. You can now say, therefore, since you put again, you say x negative x squared, or you can say since the limit as x goes to 0 of negative x squared is equal to the limit as x goes to 0 of x squared, which is equal to 0, then you can say according, or you can say and negative x squared is going to be between this x squared sine 1 over x, which is less than x squared. Okay, then you can now put comma. You say according to the squeeze theorem, according to the squeeze theorem, you can now say limits as x goes to 0 of x squared sine 1 over x is just going to be equal to 0. Here we have proved that the limit, we know that the limit of this is going to be this, which is 0. And we have just proved that these two are below and above this guy. So according to squeeze theorem, this guy, which is in between, is going to have the same limit as the other two. Okay, and that is going to be 0. And this will be your final solution for this. Now we can go to part B and solve it. Goodbye for now. We meet in part B.